Now, why do we go to all the trouble to talk about significant figures? Why do we have these rules about zeros and yada, yada, yada? The point is that we want to know how accurately we know a number, right? We don't know it to an arbitrary number of decimal places. Now, before I talk about significant figures and calculations, I did want to bring up a couple of things about numbers that have essentially unlimited significant figures. So things that are exact numbers basically are known exactly. Say something like we know that 2. There's 2 of something. That is an exact number and has essentially unlimited significant figures. It's not like we're rounding it that is, in reality maybe it's 2.15 something. No, we know there's like 2 people, right, or 2 dogs or whatever. So that's an example of something where the significant figures are not going to matter. Another example of this is something like, saying that there are 1,000 kilometers in 1 meter. That 1,000 here does not have only one significant figure. It has an infinite number of significant figures because it's a precise definition. So just something to be aware of when you're doing calculations. There are some things that have sort of unlimited significant figures that you don't need to worry about when you're thinking about doing calculations. Okay, so now we make these measurements. The significant figures, we need to pay attention to them to tell us how accurately we know something. You'll get practice with this throughout the semester. But what if we want to do calculations involving numbers that have a limited number of significant figures, that are not these exact numbers? Well, there are rules that we follow that can tell us, how many significant figures we should have in our answer, depending on the values how many significant figures are in the values we're either adding, subtracting, or multiplying and dividing. So there are different rules for our different operations. So if we are multiplying or dividing, right, so if we're doing a multiplication or division, then the number of significant figures is limited to the number of to the value with the fewest sig figs. Let's do an example. Say I am taking the number 123 and multiplying it by 54. Now the number 123, and neither of these are precise values, right? Maybe make it more clear, 54.2. So my first value has 4 significant figures. My second value has 3 significant figures. That means my answer, we go with the fewest. Since this has 3 significant figures, our answer should only have 3 significant figures as well. So if I plug this into a calculator, 123.1 times 54.2, the value the calculator tells me is 6,672.02, right? It used all the digits that are available, but we should only report to 3 significant figures. So that would give us 6670, and we ignore the rest of the figures that we had. Now, to make this not ambiguous, we could also report this as 6.67 times 10 to the third to indicate that this 0 at the end is not significant. Okay, so that's our multiplication and division. For addition and subtraction, if we're doing either of those, it is limited by the decimal place of least significance. Basically, what's furthest to the left in terms of our decimal places. So here we can't just count the number of significant figures in our values that we're using. We have to think about the decimal places. So let's do an example here. Let's say we have the number 67.251, and we are adding the number 2.2. Now, our number 67.251 is very precise. We have 5 significant figures in that value, but our number 2.2 that we're adding is not nearly as precise. It's only known to the tenths place. And so we'll limit our answer to having just going to the tenths place in terms of significant figures. So when we add these together, we will get 69 point. Now we're going to add 0.2 to 0.25, so we're going to 0.45, so actually round up to 0.5. Again, we can plug this into a calculator to make sure I'm doing this right. 67.251 plus 2.2. So get 69.451 as our result, and we're going to round that up to get our significant figure being in the tenths place. Okay, so there's a couple of brief examples, and that's how we deal with significant figures in terms of our doing calculations with them.